device, the memory on device, that is allocated by these two commands. Then we have to transfer the data from host to device, that is done by this command. Then here we are launching the kernel. So see how we have launched the kernel. N, what is N? Total number of blocks. And in each block, we are having one. What is one? Only one thread. As we have decided, one row will be handled only by one thread. That's why it is one. So this particular setup is totally changed based on the data value which you are handling. Okay? So I believe you understood that. N means total number of blocks. So how much it is? 1024. And in every block, we require only one thread, not 1024 threads. And then it is called, and then here we are calling a CUDA thread synchronization, as we have seen. So this will going to synchronize all the threads. Okay, yes. See here, one more thing I have missed. Before calling the kernel, we are calling CUDA event record. So here we are starting the timer, start comma 0. Okay, and then here CUDA event record stop, we are stopping. Then CUDA event synchronization stop. So it will synchronize and it will stop all that event. And then here we will going to calculate the elapsed time. And that is recorded in GPU time variable, right? And at last, as we know that we have to transfer the data from device to host, that has been transferred over here. And then here we can check one particular code by writing host row sum of I is equals to CPU row sum or not. If it is correct, it will continue, else it will print a message the row sum is incorrect. This is very important. Okay, so what here we are doing, we are comparing CPU results with the GPU results. If they are correct, so then there is a no issue. If they are not correct, then you have to look into your GPU code, which is exactly the kernel code, right? And then here we are making the printf and all, and then here we are making a free data from CPU, free data from GPU. So yeah, अच्छा इसको रन नहीं किया मैंने. Let me show you और कुछ रन करके रखा, इसको भी रन नहीं किया. So this is the way you can write a CUDA code with respect to one we have seen, finding the row sum. Okay. Yeah, vector addition wala code already we have seen, so that we need not to look into. We will see another one, and then I'll wait for your questions. Yes, we will see for matrix multiplication. Okay, so we are having a two matrices. As we know that the time complexity of matrix multiplication is O of n cube. That means it is one of the computation. It requires a large amount of time if n is very large, right? And here we are considering the square matrix, right? A square matrix. So yes, so what we have decided, yeah, this is the CPU multiplication. This is not that much important. Yeah, we'll look into the GPU multiplication. Okay. So in the GPU multiplication, what we require? We require matrix A, we require matrix B, we require matrix C. Matrix C is the resultant matrix, right? And then we have to decide the indices. So now this is a two-dimensional data, right? So till this point, we have seen only one-dimensional, right? So now here we have to calculate row index as well as column index. So you can see here row index is get calculated by the concept block index into block dimension plus thread ID x of y after 10 minutes. Okay, then row index is calculated by this formula, and column index is calculated by this formula. This formula we have already discussed, right? So we are getting unique addresses corresponding to row and unique address corresponding to column. Fine. Then here we are checking one condition: row is greater than height of the A, and column is greater than height. That means here we are checking for the safety. They should not go beyond the boundary. If it is, we will return. And then here we are we are writing a one for loop where we will going to perform the computation. So what is that? E is equals to 0 till a width. Okay, so here it is a symmetric. So a width or a height, whatever you will consider, it is the same. So what it calculate? A dot element. Okay, this is the formula: row into a width plus e. So here everything stored in a row measure order, as you are already knowing. So that's why this formula is very much required. So by this formula, this, okay, the one element from matrix A identified, and then it will going to get multiplied with the element with the B as per this particular formulation. Okay, This is going to get execute. You will get a C value, and then that C value will going to stored in the C matrix as per this formulation, and here the C value going to get stored. So this is not the optimized version of code, but this particular code will definitely perform the matrix multiplication very fast as compared to the regular C language code. Okay, and then other things are that already known to you, right? So this is the kernel code आपका हो गया. So let's see where we will going to launch the kernel. So see here. Here we are launching the kernel. Okay. So to launch the kernel, uh, to launch the kernel, we are using some inbuilt variable which is related to dim3. Okay, that is a dimension block. So dimension block we can specify block size into block size. So block size हमने कहीं ना कहीं specify किया होगा. Where we have specified, let me show you at the top. Sorry, okay. Block size is 16. So 16 by 16 small matrices we are considering. Okay, out of that 106 1024 by 1024. So we are considering one block. Then we are considering a grid. Okay, so here this is one of the difficult formula in this case. So that is a block width, and that the width plus block dimension minus 1 divided by dimension of block. Similarly for y dimension, so here we are creating a kind of a grid, and now these two data values we are providing over here. So dim grid and dim block. So what dim grid says, that dim grids will going to tell you this many number of blocks. Okay, okay, this many number of blocks we will going to have, and each block will going to have dim block dimension, what we can say thread. So first variable indicates number of blocks, second variable indicates number of thread in a block. Okay, and then in that particular setup it will going to perform all the computation. So here I stop at this point. If you are having any queries, your queries are most welcome.
Sir, in Google Colab, we have to run in runtime environment. So there is a two options. So which option you are supposed to select? Runtime environment, Google Colab.
नहीं, इन गूगल कोलैब रन टाइम ऑप्शन आपको लेना है. इन रन टाइम ऑप्शन यू हैव टू गो इन चेंज रन टाइम. ओके, चेंज रन
Yes,
टाइम,
sir.
एंड दैट यू हैव टू सेट अप अ टीपीयू. ये देखो, ये चीज सिलेक्ट करना है.
Okay, okay.
D4 GPU or A100 you have to select the GPU, then only it is possible. Otherwise by default it is a CPU.
And if you have select the TPU, then
CPU means it is not going to get executed, only it will going to get
then
executed
sir,
CPU.
TPU, D2 F.
D28 TPU. Oh, TPU I have not explored actually, so I have to look into it. Yeah, yeah.
So do we need to download CUDA kit?
No, no, not at all required. As I shown in the start, these are the command that you have to execute. See, this is the one cell you have to execute. Then
Okay.
this is the another cell you have to execute. This is the second. So likewise, on some particular website, you will find out all these particular code which are required to be get executed before to set all NVIDIA environment. So exclusively आपको कुछ नहीं करना है, ये कमांड ही आपका सब काम कर देंगे. You see here in this one, the second one, CUDA rep, it is downloading this particular file, which is the CUDA file.
So this can we do this on a normal laptop or NVIDIA only?
You require NVIDIA laptops, GPU. Without GPU, it is not possible. Whatever the experimentation or hands-on I have shown, these
Hmm.
are exclusively to Jupyter Notebook in terms of Google Colab. Okay? अगर आपको आपके लैपटॉप पे या डेस्कटॉप पे करना है, so there is a separate file of installation that you can easily get in, and you have to follow that all steps.
Okay. So this we
If
have.
you want to do on your machine, so I will always suggest to work in Linux, not in Windows.
Okay.
हाँ.
Yes, any other participants wanted to ask some questions? You can unmute and ask the questions, else you can comment in the chat box. We can have two, three more questions. Yes, participants, if you have any questions, please unmute and ask questions.
Sir, in the evening, we'll be doing these labs, I guess, because in the schedule it is given lab session.
Yes, yes, yes. It seems no one wanted to ask question now. Uh, Now I request Abhijit sir to
Yes,
conclude
sir. Yes, sir.
this session. Over to you,
So,
Abhijit.
yeah, thank you, Jitendra sir, for such a wonderful session. So, as you guys already know, we will resume this session on 7 p.m. for hands-on session from Jitendra sir. So, right now, I declare that this session is over. We will meet again onto the same link on 7 p.m. Please be on time. We will have a hands-on session of Pura. Yeah, that's it.
Yeah.
Thank you, Jitendra sir, for such a wonderful session.
Yeah, thank you, sir. Announcement for participants: if you have any problem in accessing your S.P.I.T Moodle account, please comment your chat box, your email IDs in chat box. If you're facing any problem accessing S.P.I.T Moodle account, request participants to please comment your email IDs in chat box. Thank you. Thank you, sir.
Okay, thanks.
Yeah.